Hello guys, so welcome to our channel. Let's learn with us. So in this video we talk about transistors. We talk about the first transistor which is being developed using the germanium, and we talk about also the working of it and who built it. So the invention of transistor is credited to the three physicists at Bell Labs: John Bardeen, Walter Brittain, and William Shockley. They invent first working transistor in 1947, and their groundbreaking work revolutionized field of electronics and laid foundation for modern computers. Now, John Bardeen role, he explained how electrons behave as surface of semiconductor. His contribution, uh, his insights into quantum mechanics and semiconductor physics help into development of transistor possible. Also, he understand that why earlier transistor not work. Because of that, the new one is being more improved. Now second, Walter Brittain. So he was an experimental physicist who worked closely with Bardeen to develop first working transistor. Now his contribution is that he created the first point contact transistor, which we also know as germanium transistor. Also, he built physical device and demonstrate how we can use this first transistor as to amplify electrical signals. Now, how this amplification of electrical signals work, we discuss later on. William Shockley, so he's the manager at the research group at Bell Lab. So he theorized and later invented the bipolar junction transistor. Uh, Now, Bardeen and Britain successfully demonstrated the first transistor, a point contact transistor made of germanium, a semiconductor material. Shockley, who's initially been focused on other approaches, later designed the more practical junction transistor in 1948, which became standard in electronic devices. So yeah, this they all get Nobel Prize in physics 1957, Bardeen, Brittain, and Shockley. So first transistor, as you can see in the photo, that there is in bottom there is a germanium crystal, and it conduct electricity in a controlled manner and act as semiconductor in form of point contact transistor. So this is a structure. As you can see, there is a wire coming from right side and also a wire in left side. In down there is a germanium crystal, and up there is a spring. As you can see, there is a spring. Okay, so working, there is a three main part which also repeated in today modern words also. The pass in and out of the current pass in and out. For example, in right side this electricity come, and from left side it is goes out. Now this uh, important component of it are first emitter, second one is base, and third one is collector. Now germanium uses, so first transistor developed in late 1940 used germanium as semiconductor material because it had better electrical property at that time. So using of germanium basically, because that at that time it has better electrical properties. Now semiconductor properties, basically germanium has a narrow energy gap, band gap, making it more conductive than the insulator, but still able to control the flow of electrical current, which is essential for transistor functionality. This made it ideal for earlier transistors which were used to amplify or switch electrical signals. Also, germanium has lower resistance to electron flow. Because of that, it can also be used in amplification. And in 1940 to into 1950 it is more readily available in high purity. Also the technology we use currently, the silicon one, at that time there is no technology for to purify it and to make it, so it developed later on. But the problem why we in today world not using germanium, rather we use silicon, because it is sensitivity to temperature. Means silicon has wider band gap and more stable at high temperature, but this not same with the germanium. When the temperature goes high, germanium cannot function and work in same manner as silicon does. So this is the chart. As you can see, first one is BJT, and inside it there is NPN and there is PNP. uh, there is a second one, field effect transistor. Inside it there is a junction FET, and second one is metal oxide semiconductor FET. This metal oxide semiconductor is what transistor we use in our CPU and all other functions, basically. So it we discuss this in next video, part 2 video, but in this video we talk about BJT and NPN and PNP functions and all that. So let's start. So this is BJT, full form is bipolar junction transistor. Again, this is name is bipolar junction transistor, one of the earliest made with germanium work and how it managed currents. So as you can see in this in the picture, this right side it has emitter, means emitter. As you can see, where the current enter. Okay, from emitter the current enter, and there is a base. This germanium is a base. Thin middle layer that control current flow. So this is gonna control the current flow. And on the left side you can see collector. Its work is to exit that current, the current exit from this collector. uh, Now, two main type in BGT is NPN and PNP. So current flow from collector to emitter, from right side to left side when base is activated. When base gets activated, current flow from right side to left side. And PNP, current flow from emitter from left to right when when base is activated. Okay, so the NPN is reverse of PNP and PNP is reverse of NPN. Okay, sorry, here came deactivated in PNP. Now, current flow in germanium transistor. As you can see, positive from right side and negative from left side when the current exit. And this base germanium base work as control terminal. A small current is applied here to control the large current flowing from the collector to emitter. So as we discussed that this germanium transistor is also work as amplify the current coming from. How it works? For example, a small current at the base, the transistor allow a much larger current to flow from the collector to emitter. This means the transistor can take a small input signal like a weak audio signals and amplify it to a strong signal. How it works? For example, the current comes, the small current. For example, there is a large wire or large connection, for example, and a current came. So we use this germanium transistor as amplifier. When current came from right side, the collector lead, it goes to germanium and it amplify, and when it exit from emitter, it amplify the signal. The signal came in the low band after going through the germanium, and when exit from the emitter, the signal strength is being increased. So this is how it also work as amplifier. Now this is a example how, as you can see the example, when water is flowing, for example, we also showcase it using water and tap example. For example, when gate is closed, it is off, the sink is empty. When we open the gate, the sink start filling. So this is like how a transistor also work. Now a germanium transistor can perform amplification and switching, which are building block for more complex operation like addition in digital circuits. Now switching. So the base or the most important work of a transistor is switching, means to work as on and off and and to do the binary functions. For example, when the base receive a small current on, which is represented a binary 1, it allow current to flow between the collector and emitter. When there is no current at the base, it represent by off, binary 0. So this is how switching works. Now a main questions goes around everyone, then how do the and or and not gate perform their functions. So basically, we we arrange these transistor in a way so that these logic gates function are being performed. So as we know, AND gate output 1 only if both input are 1, and OR gate output 1 if either input is 1. So this is the basic concept of logic gates, which we all know. If you not know basic concept of logic gates, you just watch my video on logic gates, you get clear idea how it works. Now this is the some basics of how germanium and when starting, and how to start, and what is the basics of transistor when it is being built. So this is all in this video. If you like this video, uh, like like uh, like this video, then press like button. And if you not, and if you think there is some mistake, and you want us to improve, you can just comment down what you feel that we have to improve. Till then, see you in the next video. Thank you.